Yeah, that's what she was like. She was like, I'm not talking about you. You give my stuff back. It wasn't in
Does everybody have the liquor card?
Yeah, I got it.
Alright, so it's the start of a new quarter. How long you have assigned seats depends on how long it takes to keep you from talking. So if I gotta keep stopping until you be quiet, it's gonna be a while for you guys can sit where you want. New quarter means we start over with grades, everybody starts off with 100. Your first grade will be your benchmark test, and then how you handle your grades after that is up to you. Technically, your schedules probably won't come to you until Thursday or Friday, because grading for the new quarter starts today, but your schedule for the new quarter won't start until later in the week or next week. Yes.
No, we keep the same classes.
Core classes, yeah. Just electives may change depending on the electives.
So I got band.
Band would not usually, but Jimmy probably would.
Yeah. I don't want to now.
You selected, I
You
know.
got them.
I want you.
Alright. So we're moving away from chemistry. We will be talking about it occasionally, because everything we do in science usually ends up going back to some form of chemistry. And you'll see that in a minute with our clickers. We are moving into earth science, more specifically earth history. So we're gonna be talking about the formation of the earth and how it's changed. We're gonna talk about evidence of change in organisms and earth's surface. Bless you. We talk about evolutions and adaptations, and we're starting off with fossils, which is one of the evidences to show change. We cannot talk about fossils without talking about rocks, because rocks and sediments have a lot to do with how fossils are formed. The rock cycle is something you guys learned about starting in like first grade, and you learned it a few more times through elementary school, and then the last time you should have learned it was in 6th grade. So we're just going to go and see what you remember. Reminder on using these clickers. You turn it whichever way you want to answer. So on here you have, depending on which side you have A, B, C, or D. The number, don't worry about, that's just an identification number. Depending on what your answer is what side you hold facing up. So if my answer is A, I'm going to find A, make sure that A is on top, and that's what I'm going to hold up. And then if you need to change your answer, the next question, just turn it a different way. Make sure you're holding the card straight on. Make sure your fingers aren't covering any part of the block. It won't read it. Make sure you do not hold this up at all until you are ready to answer, because if you, let me think about that answer. I'm going to scan it and it's going to register whatever this is, whether you want it to be your answer or not. Once you see your name highlighted on the screen, you can put your card down. Yes. Not personally, but I will tell you what the right and wrong answers are. Okay. If you remember clickers from back a few weeks, no, several weeks ago, when the last time we did this, the format may look a little different, but I really like the layout of the way they have it now. I think it's a little easier to read. All right, so with true or false questions, true is A, false is B. There should not be a C or D option. Your first question is, sedimentary rocks form from rock and mineral fragments, and metamorphic rocks form from existing rock. Is this true or false? Select your answer, then hold up your card. Once you see your name highlighted, put your card down. Move your finger a little bit. There. There you go.
Are you doing causes against us?
I'll think about it. All right, the correct answer is true. Sedimentary rocks form from rock and mineral fragments. So fragment, pieces, particles, those are all sediments, which make sedimentary rock. Metamorphic rocks form from existing rock. They just go under heat and pressure. Oop, wrong one. Go back. All right, the processes involved in the rock cycle include all of the following except which one? Condensation, erosion, weathering, or compaction. Which one does not have to do with the rock cycle? The answer is A, condensation. Y'all see weathering and you think weather. That's not it. Weathering is the wearing down of something by either chemical or physical means, not the weather. Condensation, we learned that in chemistry. Here we are touching back on our chemistry unit. It changes a gas to a liquid, so it has more to do with the water cycle than it does the rock cycle. Sedimentary rocks are changed to sediments by what? A, heat and pressure, B, cementation, C, weathering and erosion, or D, compaction. Wait. How are sedimentary rocks broken down into sediments? All right, the answer is C, by weathering and erosion. When you have rocks that are undergo weathering, that's breaking it down. Erosion is moving it somewhere else. Igneous rocks form from what when it cools? A, magma, B, lava, C, neither, or D, both.
Isn't it magma and lava the same?
Why are you like talking out loud? Oh, wait. Alright, the answer is D, both A and B.
A and B are the same thing.
Not exactly, but kind of. Magma and lava are both molten or melted rock. Magma is melted rock under the Earth's surface. Lava is melted rock that comes out onto the Earth's surface, like from a volcano. Both melted rock, though. Ooh, I have to come over here and plug in my phone while I stand. Sedimentary rocks are what?
You already told us what it is.
Everybody lit it up, right?
Yeah, yours.
Pointed at me because I have to stay plugged in. This drains my phone battery big time. All right. Answer is C. Extreme temperature and pressure cause what to change to what? So igneous rock to sedimentary rock, metamorphic to igneous, sedimentary to metamorphic, or metamorphic to sedimentary. What is caused by extreme temperature and pressure?
I'm just kidding. I mean, it's been so long.
I guess.
All right, the answer is C.
Oh, let's go.
Anytime you have the words heat and pressure or temperature and pressure, it's always metamorphic rock. So you could have been able to get rid of A, B, and D because none of the other ones form metamorphic rock.
Metamorphic rock. It's from already kind of rock.
It's from what?
Under the rock.
Yeah, any other rock can turn into metamorphic rock as long as there's heat and pressure. Alright, the rock cycle indicates that each type of rock can what? A, be changed by forces at Earth's surface. B, form other rocks. C, provide materials to make other rocks. Or D, all of the above.
I ain't doing that work.
Alright, the answer is D, all the above. That's why they call it a rock cycle, because it can form other rocks, it can give pieces to make other rocks, and they're all able to be affected by the changes at Earth's surface. Melting causes what to change into what? Which one of those options? Back up.
Oh.
I'm guessing on this.
Oh, I heard this. You didn't just say. You just heard it.
Did it light up my name?
I swear.
Yeah.
Mine is probably wrong. Yeah,
Alright, the answer is B. Most of you got this right. Again, anytime you have rocks that melt, not heat and pressure. Heat and pressure doesn't necessarily melt something. But if it's hot enough to melt, it changes it to igneous rock. Weathering and erosion changes what to what? I feel like this is like the fourth time we've asked this question.
I feel like I'm asking the same questions.
And yet people get them wrong.
That's good stuff.
That's what you get for guessing. Oh, Lord.
Oh, just look.
Should be able to eliminate two of them right off the bat. And who's holding it up? There we go. Javon, you're one of the only ones that got it right. All right, the answer is C. Igneous rock to sedimentary rock.
I put that.
I did too.
You could have eliminated A and B right away.
That's all I put C.
Then I didn't say you got it wrong.
Is this a grade?
Don't ask me if stuff is a grade, because every time you ask me, it makes me want to double the grade. Assume that everything I do is a grade. You could have eliminated A or B right away, just because it doesn't talk about sedimentary rock being made. Only C and D result in sedimentary rock. So with that one, it can't be metamorphic because it talks about weathering and erosion, which happens at the Earth's surface. Metamorphic rock has to be deep under the surface to get that heat and pressure. So you should have been able to narrow it down to a 50-50 chance. All right, I need somebody to collect the cards, please. All right, so later on in the week, we're going to be doing, thank you, stations. We're going to do a little bit of exploring, and I'm going to include some actual fossils that you guys will be able to look at under the proscope.
What about the little window?
Yeah, I gotta take this back. You don't want them back, so unless we finish the books. So with looking at fossils and a couple other hands-on things I want to do, y'all know first we gotta get our vegetables so we can have dessert. So let's get the vegetables out of the way. It's been a while since we've had to take vocabulary notes. I'm gonna remind you how to fold, cut, and all that good stuff so that you guys don't freak out about it. Don't you, Mike! Get him, physical. First day of school.
Oh.
I just want to try it.
All right, reminder. You're going to cut out, listen, cut out everything that is bold. Fold the dotted line. So when you're done, you'll have one half that's solid with no cuts on it. And then you'll have tabs to put your words on. So fold the dotted, cut the bold. Let's see. Just the bold stuff. So cut around the whole thing and cut those lines. Only one half is cut in tabs. The other half should be left alone.
If you had Hispanic or black, or Asian, should be out there. I don't know if my mom's Hispanic. I know how
Do not glue this into anything yet. You want to write first and then glue so that it doesn't mess it up.
Now, what side do we write it on?
But you look here like a Tuesday.
Alright, listen. And look. When you're done, you will be able to put the vocabulary word on the outside of the tab. When you open it up, the definition's going to be on the inside. These are like flashcards that permanently stay in your notebook. So, word on one side, definition on the inside.
Can you come explain?
Yes.
Your big food.
Then you have to make sure you glue it in when you home. Just right on it and then don't lose it when you go home and leave it.
I would. See how big my hand is?
Alright, turn your voices off so we can get through this. Thank you. Alright, everybody knows what fossils are, and you've probably seen fossils at some point in time. What is now known as Palladium North. It used to be known as SciWorks, and before that was known as the Nature Science Center. They had a few specimens of fossils at their location before, and if anybody's ever been to I think they have some at the Greensboro Science Center, and I know they have some at the Raleigh Museum, North Carolina Museum of Natural Science. Those are the ones that have like the replicas of the Tyrannosaurus skeletons and stuff.
Oh, in the Greensboro, that's perfect place.
Yeah, they have it in the dinosaur museum.
Come you wait.
Mhm. Hey, stop talking so I can get through this. The definition of a fossil is preserved remains or traces of living things. So they can be actual preserved organisms or evidence of the organism. So a dinosaur's footprint that has been preserved is still considered a fossil, even though it's not the actual organism. Finding a burrow where some creature has dug underground millions of years ago, if you can find one intact or preserved, it's also Oscar, move to the table, please. Zara, you about to step out of my class.
Huh?
You about to step out of my class. You think that's funny?
Right now?
Yeah, you can step out. Step out. If not, be part of this class and be quiet. Quit moving around.
How? I'm doing my work.
You doing it, Oscar?
Yeah, doing my work.
Mm-hmm. Mummies are a type of fossil. They are preserved remains of organisms. Do y'all remember studying mummies back in 6th grade when we studied the Egyptians? Yeah, ancient history. So, mummies are a type of fossil. Austin, eyes are up here. Where the Egyptian mummies were preserved by embalming, there's also another type of mummy that has been found recently, I believe in Argentina. And I lost the, let's see, this one. Not too long ago, let me go away, add. This was 2007. They found a mummy, a preserved girl, in ice. You remember seeing that?
Oh.
Oh.
This is a teenage girl who was found in, I think they said down at least 20 feet into, they dug down in ice and snow up in the mountains of Argentina, where it never melts there. It's always ice and snow. So she's been preserved since her death for all those years. They think she dead.
She alive, boy.
But this is exactly how she came out of the ice. Her clothes, her hair, everything is perfectly preserved. They said it looks like when she first got covered in ice or snow, she'd only been dead maybe a few weeks at the most. So she was
She was there before.
She looked like she was going in labor.
okay.
She was there before she was in the ice.
Yes.
Come along.
Thought she was gonna be like Captain America.
She no.
She's dead.
They said that she was so well preserved that you could actually still see like the tiny hairs on her arms. And her and two younger children, so she was a teenager, and then two young children had died with her, and they believe they were sacrifices for the Inca civilization because the Inca considered children to be the most pure, so were the highest sacrifice. The younger of the children, the remains were not as preserved because apparently at some point it had been struck by lightning. But besides that, they said that the remains, like the organs, were all in really good condition, almost perfect condition. The brain was in perfect condition. They said one of them still had blood in their heart. They thawed out one of them, and their blood came out crimson, which is like a red color that living people, that's what color living people's blood are. So you want to talk about being preserved very well. It was pretty amazing, being that the clothes didn't get disintegrated or anything. Yes. They said that, all they said was that she was sacrificed. They didn't say how, that they believe she was sacrificed. They have her in this box right now, and that box is kept at negative 20 degrees Celsius, and they have taken out all the air. It's pressurized so that she doesn't get freezer burn damage to the skin. So she's going to stay preserved like that. And I believe it's in Argentina, a museum in Argentina. So I thought that was pretty cool. But she's technically a fossil. She's preserved remains of an organism long ago.
I'd be scared.
That's creepy to me. I could not be alone in that museum with that girl.
I wouldn't see it either, because I'm pretty sure she'll wake up with everybody.
I've seen the movie The Mummy. I know what happens. All right. So that's one evidence of a really cool fossil. There is a specific kind of fossil called an index fossil. Now, this question has been a struggle for classes today, but let me ask you. Do you know what the index of a book is for?
So it can tell you where stuff is.
Thank you. So it's the back of the book, and it tells you where something is. So if I want to know in my science textbook where fossils are, what page they're on, I go to the back of the book where the index is. I look in alphabetical order, just like a dictionary, for fossil. It says, okay, fossils are on page 365 to 368. Okay, thank you. Index fossils work kind of the same way. There are certain organisms that only lived for a short period of time and then became extinct. They were only around a fraction of the time in Earth history. and they were located all around the globe. So when paleontologists dig up fossils and they find an index fossil, they can tell you exactly how old everything was in that layer because it had an index fossil. Well, this fossil, these organisms only lived from such and such million years ago to such and such million years ago. So these other fossils must be the same age because they're all together. One index fossil, the most popular one probably, is called a trilobite. This is a 3D printed version of a trilobite. They are extinct. They've been extinct for millions of years.
Oh, wow.
They are relatives of the horseshoe crab. Y'all seen horseshoe crabs? If you go to like the Greensboro Science Center, they got that tidal pool that you can like touch the manta rays and stuff. I think they have horseshoe crabs in there. They don't look like crabs really. They look like just horseshoe-ish shaped, U-shaped shells.
Did you make it?
And then they have like their little crab legs on the bottom and stuff. Now, trilobites are like that in that they have the hard shell on top and they'd have their little spiky legs on the bottom. But unlike horseshoe crabs that just have the shells, trilobites could curl in on themselves and protect themselves kind of like an armadillo.
So basically, a roly-poly.
Like a roly-poly. It's like a roly-poly and a crab had a baby. Trilobites are a great index fossil. They were found all over the globe, but only for a fraction of time, and then became extinct for whatever reason. So if you're a paleontologist and you're digging down and you find a whole bunch of fossils, you're like, oh, look at this, I wonder how old they are. And you find one of these guys mixed in with them, then you know they all came from that one particular time period, and you can age those fossils really easily.
I'd be scared of it, man. I ain't holding it. Oh, but I'll sit.
Miss Bobby, did you make that here?
No, I made it at Winston State on their 3D printer, which is the same type of 3D printers we have here.
I was just very
We got a 3D printer.
We have two here
Where?
in the library.
I want to use one.
Do we use them?
In
You
sixth
can.
grade, they said that we was the
Let's
first
do it.
How much does
class
it
to
cost
ever
to make
use
one?
Yeah,
Make
Like a
something
student
out
can
of
use
it.
Yeah.
Technically, if it's for like a class project, so I had last year I had a sixth grader who designed a model of a vehicle that could travel to the center of the earth because we were studying like planetary layers or whatever. And he made the design on a 3D modeling program and had it printed out. So it can be done. You can't just like print out whatever, you know. I mean, I printed out Pokemon and stuff before, but that was for my kids, not for me. You can't do that, but if you have a school project, like your Genius Hour project, a lot of people are doing that, studying 3D printing in my home base for the Genius Hour project.
I want to print that.
All right, anyways. Law of superposition. Looks like a big word, but it's really just two words smushed together. What does the word position mean?
Spot.
Spot, location, where you at. What does the word super mean?
Superman.
What do you think of when you hear super?
Superman.
Powerful.
Superman.
Powerful, okay.
Unique.
Unique, okay. What else?
Have powers.
Not exactly. Oh, let's think about that. Superpowers. If you have superpowers, you have powers that are greater or above the average person, yes? So, superposition,
Means
you're
you're above.
above or greater than the current position. Yeah, you're above whoever you're looking at, basically. So, law of superposition is a geologic, which means the study of the earth. It's a geologic principle that states that horizontal layers of sedimentary rock, each layer is older than the one above it. And it's younger than the one below it. Think of a stack of pancakes. If you're making pancakes and you're putting them in a stack, which is the freshest pancake?
The one on the top.
The one on the top. Same thing with sedimentary rocks. The youngest layers are on the top. The further down you dig in the earth, the older the layers get. There are exceptions to that, but this is the general rule. If there's no disturbances messing up this order, this is the law of superposition. I want to try to do an activity with this, but I gotta see if I can get all the materials. It's a pretty easy concept to understand. However, you will have instances on quizzes, tests, benchmarks, especially EOGs. They love to put this on EOGs, where you're given a model, like a diagram of layers of the earth. Okay, these are rock layers A, B, C, D, and E. And they'll say, which one is younger, layer C or layer F or whatever. And you have to know the law of superposition means that the bottom layer is older. All right, when we're talking about the age of things, there are two different ways we can say age. We can say absolute age, or we can say relative age. In the absolute age, what do you think of when I say absolute?
Exact.
Exact. Absolute is a specific value. It's the age of a rock or fossil given as the number of years since it was formed. So it's a number. Don, how old are you?
14.
14. Derek, how old are you? 13. So, Don is 14 years old. Derek is 13 years old. Those are absolute values. Ooh, I like that. Those are specific. We've given them a number. That's the same as saying this rock is 6.5 billion years old. It's a number. Now we have to use special types of measurements to determine the absolute age of rocks and fossils, and we'll talk about that in a minute. But if we were talking about relative age, relative meaning like general, it is the age of rock compared to the ages of rock layers around it. So that would be like me saying Adon is older than Derek. Or Ms. Thomas is older than her students. I'm not using a number, and I'm not gonna. I just use a general description. This is where the law of superposition comes in handy. I can tell you that that rock layer is older than the layer above it. I'm not giving you a number, but I'm giving you a relative age. I'm comparing it to the rock layers above and below it. Who still needs to get absolute age? Anybody good? I'm moving it up. All right, I don't want you guys to blow your minds on the next couple of concepts. It can be a little confusing, but we're going to keep working with it until you get it. If I need to know the absolute age of something, I need to know the number. How old is it? Then I need to use a thing called radioactive dating. Not dating like, would you go on a date with me? It's how old something is. Radioactive dating, you're determining the age of an object using what's called half-life of radioactive isotopes. Miss Thomas, that was a lot. What's all that? Okay, let's talk about isotopes first. We've mentioned this before briefly in chemistry. But if I have a carbon atom, its atomic number is 6. How many protons does it have? How many electrons does it have? 6. Generally, atoms have the same number of protons as they do electrons, and vice versa. However, there are exceptions to that where they may have more or less electrons than protons, and those are called isotopes. So carbon-14 does not have 6 electrons. Neither does potassium, uranium. They have a different number of electrons, so they may have 14 electrons. And these are called radioactive isotopes. Everything in nature has a little bit of these radioactive isotopes in them, even us. We have radioactive isotopes in us. That doesn't mean we can power a nuclear plant. It just means that that's a trace of our life. It can be found in rocks, it can be found in bones, anything in nature. The way we find out how old things are is by determining what the half-life of these isotopes are. Usually it's carbon-14. That ends up being the most common one. What half-life is literally what it means, half of a life. So instead of lives of humans, we're talking about lives of radioactive isotopes. Those carbon-14s or potassium-40s or uranium-238s, those isotopes only last so long, and then they're gone forever. We measure those radioactive isotopes by half-life. So for example, if carbon-14 has a half-life of 6,500 years, that means every 6,500 years, half of the radioactive atom decays. It's only got half the amount of radioactivity it did 6,500 years ago. And then in another 6,500 years, half of that will be gone. And it'll keep cutting in half, cutting in half, cutting in half, until there's nothing left. So if we measure how much of the carbon-14 is left in a rock or bone, then we can determine through some backwards math, a little reverse math, how old that specimen is. I will probably do an activity with this that involves Twizzlers that I really like doing previous years. Y'all have to eat them because they're Twizzlers. This is the last word, and it's I cannot say this word without reading it. Uniformitarianism. This is a spelling bee breaker right here. So uniformitarianism. I don't spend too much time doing that. You can't get the words. What does the word uniform mean? What do you think of when you hear the word uniform?
Cool clothes.
Same. We talked about that with mixtures and solutions. If it's a uniform mixture, that means the mixture looks all the same. There's no pieces of it that stand out. So uniform usually means the same. And this is a geologic principle that says the processes that are happening today on Earth, like erosion, volcanoes, earthquakes, plate movement, that all that stuff that's happening today also happened way in the past. So the same things that are going on today happened millions of years ago as well. Which makes sense because it's not like volcanoes, earthquakes, and erosion are brand new things. They've been going on a long time. This Earth was full of volcanic activity before there was ever life on it. And because of that principle, we can make predictions about what is going to happen when certain processes are going on. What's going to happen when there's a volcano? erupting in this certain area. What's gonna happen with heavy amounts of erosion in this state? Well, what's happened before? Let's study that, and that way we can make predictions. Alright, that's the basic lingo we'll be working with this week. So when you're done, glue that in onto page 31. Make sure your table of contents is up to date.
What was on page 30?
Wait, what?
30?
It should have been pros and cons of renewable energy, I think it was.
We got further
I got that on 29.
Yeah.
What are we doing? Page
Either you
30?
wrote real tiny or you're missing something.
What page is it going on?
Make sure your table of contents matches what you got in your notebook. And make sure you're not missing anything. Not yet. Yes. Grab some of that.
We watched the movie Orphan.
Where's the this one?
I am late.
What do you put this on?
Oh, I'll be.
Around. What do you do?
Alright, whenever you include that in, don't cut out what I just handed out, and we'll take a little bit.
You know how to do it. How you do it? Like, how you do it? All right, how you do it? You go like that. You know how to do it? My finger here.
Love how y'all are cutting on that.
This one. What do we do this?
What she said. Oh, he said. Oh, he's doing it. Text back. I want to say something in person. I want to say something in person.
I mean, some people can find them on the beach. I'm not that lucky.
What's the deepest part of the world?
Well, I feel like I'm moving on. You know, that's where you go on there. It's the same way. She's not going to me back like
right. Take it down. All right, what I just passed out to you were examples of fossils. We're gonna be working on those today and tomorrow. We get to be paleontologists. First, we need to talk about why in the world would we dig up dead stuff and study it. That's what we're gonna talk about.
We gotta write that in the notebook.
Nah. Yeah.
I thought you was for real when I said, nah, I was
Why
about
would
to
I-
say,
I would
Be happy.
I'm definitely good at remembering stuff. I've got good test.
Math is one goal you should have.
My goal is to take you on.
Especially, I know you can do better.
But I read like 3 questions wrong.
All right. So before we talk about types of fossils and what makes them different, we need to talk about why the heck do we study fossils. So Cornell style notes, we're putting our question on the left side. Why do we study fossils? Why are paleontologists paid to do what they do? Why do anybody study history of anything?
Do they even get paid that big?
Most of their money comes from funding. They don't get like money. They get their money from like writing books and stuff.
That's a waste of time.
I mean, they're not poor or anything. All right, so we study fossils the same reason why anybody studies history is to learn from the past. I mean, you might have legit curiosity about it, which is cool, but we want to learn from the past, see those patterns, and be able to make plans for the future. We're going to learn, just like you learn from your mistakes, we learn from our past.
And you learn your lesson.
And fossils are the perfect evidence of what happened in the past, way before mankind ever had the written word. So why we study fossils, one reason is to provide evidence of how life and environments have changed over time. So not just we're learning about the organism itself, we're learning about the environment that it was in. And we're also learning about how those environments changed and what caused them to change. They change in a good way or a bad way. Also, we study fossils because they show the diversity, which means how different living things were over Earth's history. So it shows us that at some periods of time, there was a wide variety of organisms. And we're studying to find out why certain ones lived and certain ones didn't. What caused them to be different? Did some of them change? Did some of them adapt or evolve? Has anybody ever heard of a climatologist?
What? Somebody that studies the climate?
It is. Climatologist. Who's seen, what's that movie? Day After Tomorrow? Dennis
What is
Quaid?
that?
Yeah.
Oh, whenever they touch that little coin in that movie.
No, this is the one where there was a super hurricane that froze over everything and
Oh yeah, I see.
there was like tsunamis and stuff.
I was
So
bored.
Dennis Quaid played the climatologist. You remember the beginning of the movie where he's digging into the ice breaks open, he almost dies?
Yeah.
Okay, he was trying to get an ice core. And the ice core, you're making me feel old, stop. That was my favorite movie. So, at the beginning, if you watch it, like 1,000 times a year,
Probably the only movie I've
they
seen. Ice cream man.
looking for ice. You about made me say ice cream. Stop. Huh? No, you didn't even watch the movie. So they were drilling for the ice core, and we'll talk about ice cores later in the week, because he was trying to figure out how the climate changed. So fossils and rocks and other evidences can also tell us how the climate changed, as well as the surface of the earth. So if a scientist found evidence of a huge climate change and high levels of carbon dioxide in the atmosphere, more than likely there was something like a supervolcano during that period of time that altered the Earth's surface and the climate. So if we can figure out what happened then we can figure out how to prepare for when the next supervolcano happens. 'Cause it'll happen, it's just a matter of when.
Yellowstone. It's gonna be in Japan. It's gonna destroy the whole Japan. That's messed up, but I think it.
I think it'll be Yellowstone,
What's that? Yeah,
the
where is
US,
it?
the Midwest.
It's like that huge bone.
It's
What's
that big
Yellowstone?
national park,
The
the
really
big national park out west.
they be going there too.
They have bad volcanic activity out there.
Yellowstone.
Mhm.
Watch me not come back.
Alright, last thing. We study fossils because they tell us how organisms have changed over time. So this is how organisms have evolved, how they have adapted, have their populations grow, did they go extinct? Fossils can tell us all that. So we talked about the why. Now we're going to be talking about the what. So different types of fossils, they're based on how they formed. The difference between one kind of fossil and another is just how they were formed. It could be the exact same organism we're looking at, but if the fossil was formed two different ways, they're two different fossils.
So if it was the same birds, they were formed two different ways. They two different fossils.
If you had a mold of a Tyrannosaurus rex and a trace fossil of another, they're formed different ways, but the same creature. The first type of organism we're going to talk about is a mold fossil, which is it is fossil C, which is the seashell looking one. So that little seashell, the curly seashell looking thing, it's called a nautilus, I believe. This guy, this fossil, is a mold fossil. Anybody ever had a mold taken of like their teeth?
Yeah.
If they had to get braces or dental work or something? Or a lot of athletes will get custom mouth guards made so they have to get mold of their teeth. This is the same idea. What happens is an organism dies and it lays there and it's covered in sediment, in pieces of rock and dirt and sand. Over time, that sediment is compacted and it's turned into sedimentary rock. So the sediment hardens around this dead organism. The organism still decays. So eventually all that's left is the hole that it was in. So a mold fossil is not the actual organism. It's mostly just the space it took up. You'll see a lot of these on animals that didn't have very thick bones. They may have been very delicate, or they may have been more with tendons and cartilage than bone material, because tendons and cartilage degrade a lot quicker. So this is the picture you're going to want to put next to your definition. You have probably just enough time to cut that out and go in. I would not cut out all of these squares right now, because you're going to lose them between now and tomorrow. I would just cut out that middle one and glue it in, and then tuck the rest into your notebook where you can find it tomorrow.
Well, we may be allowed to do that.
What's the word after organism?
Oh, yeah?
Okay, you said cavities.
I felt insecure with
I don't think I might be smart, but I forget.
Must be like you're more
You said what insecure means?
Yeah, I forgot what insecure means.
It's like, I don't even know.
What?
nice to be smart.
Huh?
Must be nice to be smart.
I may be smart, but I forget little things.